So now we're going to move on to the conversation about compounds and formulas. Our objectives for this lab is to understand the relationships between ions in a compound, learn how to write chemical formulas for ionic compounds, and learn how to name them. So let's go over some terms first. So the atom is the smallest part of an element that retains its chemical properties. Compound is a substance which is formed by a combination of two or more different atoms of different elements. Element is a primary substance that can be broken down into smaller substances and therefore consists of the atoms of only one kind. So water would be an example of a compound, but hydrogen would be an example of an element. Formula reflects the arrangement of atoms in a molecule. Now, ions. Ions are atoms that either gained or lost one or more electrons. Atoms that gain electrons become negatively charged. We call them anions. Atoms that lose electrons become positively charged. We call them cations. Molecule is the smallest granular unit of several atoms held together by bonds, by chemical bonds. Neutral charge is when total number of positive charges equals the total number of negative charges. And finally, polyatomic ions. So this is what it's going to be polyatomic, mostly anions, covalently bonded atoms that has a charge. The example of polyatomic anion would be sulfate or hydroxide or phosphate. They're polyatomic, but they have a charge as the polyatomic structure. Okay, so we didn't go over this we didn't go over this exactly in the lecture notes yet, but atoms here have equal number of protons and electrons, so they're neutral. But in order to complete the outer shell to the noble gas electron configuration, a noble gas arrangement, they are going to be either losing or gaining electrons. Generally speaking, atoms that are on the left side, let me see if I have a periodic table here. I should. I hope. Yes. So the atoms that are on the left side of the periodic table right here, they are more likely to lose electrons. Atoms that are on the right side more likely to gain electrons. Okay, so this is how it all plays out. Now, when they gain and lose, when they gain they become negative, when they lose they become positive, and negative and positive charged ions, they attract to each other. And importantly, the ionic compounds have very much different properties compared to the original elements. If you would look at sodium as an element, it's malleable, very soft, very reactive metal. Chlorine is the gas. If you combine sodium and chlorine, you get sodium chloride, which is a table salt essentially. And the ionic compound, as we already mentioned, it is a neutral compound. So let's learn to write formulas for ionic compounds. Positive element always goes first, and it follows by the negative element. So sodium is positive, it's on the left side of the periodic table. Chloride is negative. Or lithium is positive, left side of the periodic table. Sulfur is negative on the right side. Then you have to write down the charges. Sodium is positively charged and chloride is negatively charged. In lithium sulfide, lithium is positively charged, while the sulfur sulfide anion is negatively charged, -2. How do you know what is the charge? There are rules, but generally you just will have to. A lot of it comes from experience. You will memorize eventually by using these terms. So in sodium chloride, positive charge is equal to the negative charge. So that's your formula for sodium chloride. Now if the charges are not equal, look what we do. You basically do this crisscross. So lithium is +1, check this out. So you do this cross and you say sulfur is going to be just one atom. But sulfur is -2, so you need 2 lithiums to balance it out. Do you see that? So 2 lithiums with a positive charge +1 gives you 2 positive charges. Make sense? Which balances out 2 negative charges from sodium. Okay? So this is exactly what's written here. Okay? It's written as lithium 2s, so 2 lithiums, 1 sulfur. Subscript 1 is never written actually. Okay? So using this example here, sodium chloride, 1 sodium, 1 chloride. In lithium sulfide, 2 positively charged lithiums for each sulfur which is double negatively charged. Okay, so these compounds will also always have those formulas. Now we're going to move on, and then we're going to work on some compounds here. So polyatomic anions. Here's the polyatomic anion. Look, it's a phosphate. Without going too much into the woods, that phosphate, as the whole thing, the whole anion, has a negative charge of -3. Please understand that this -3 here doesn't belong to oxygen or phosphorus. It belongs to the entire phosphate. Is that understood? So you write them down next to each other. Now look what happens. You see -3, so it's got to be 3 at calcium. You see +2, it's got to be 2 at phosphate. Now look at the check. Look, 3 ions of calcium, and each of these ions carries 2 positive charges, give you, check this out, 6 positives total. Is that understood? 2 phosphates, and each phosphate carries a -3 charge, give you -6 charges total. +6, -6, cancel each other out. The whole compound is neutral. We're good. Formula is perfect. Does that make sense? Naming. I already mentioned the positive one, the metal ion like sodium or lithium. We just call it by name. Sodium, lithium, copper, iron, you name it. The non-metal ion, if it's the single element, the end is replaced with "ide." So chloride, okay, sulfide, bromide. Following so far? Nitride, selenide. Okay, Now, what about polyatomic ions? Comes with experience, you just learn it. So there's a list of polyatomic ions here. It's basically on the cover, the inner cover. Okay, so that's the book. Flip it. Here are the ions. Okay. You need to know the charges. They're not here. Okay. We can write them down. So they're all going to be -1, -1, -1, -1, -2, -1, -3. Sorry, -1. I'm sorry. That's good. -1, -1, -1, -1, -2, -1, -1, -2, -1, -3, -2, -2. Okay? There's probably some printing problems. Okay. You don't have to worry, Janae. It's all recorded. I'm going to upload it like once we're done with the lab. So let's go back to some naming. So now what you're going to need to combine, I'm going to give you one example, absolutely random. So we're going to take calcium and nitrate. Okay, you write this down like this. So calcium is 2 charges, look, 2 positives. Nitrate is 1 negative. How do I know? We go back here and find nitrate. So how do we project? This gives you 1. We don't write subscript 1, right? And this gives you 2. So the final formula will be calcium NO3, calcium nitrate 2, and the name will be calcium nitrate. Again, you can look up the name in this part of the book. So you have to fill out the entire table and submit it as the part of this lab.